we're now going to Germany to Philipp Nicklaus, who's the regional sales manager at AB Energy in Germany. I don't believe it's Philipp's birthday today, but he has a wonderful gift for us anyway, by way of a presentation into a district heating success story from Germany.
Correct.
So Philipp,
please,
over to you.
Let me know if you can see the presentation and if you can hear me well.
I can hear you absolutely fine. We can't see your presentation yet. Oh, there we go. Now we can.
Perfect. Perfect. So first of all, I wanted to thank you for the possibility to speak here today, and also for the very interesting introduction and the presentation about Malaysia. Very interesting. I will now come up with the next case study for Europe, especially like you mentioned already for Germany. And before jumping into the case study itself, I want to say some words about the company I'm working for. It's the AB Group. I am located in the German subsidiary in AB Energy Germany. And the AB Group, as it is a family-driven company, which is for 40 years already in the CHP sector active. And we have installed in this 40 years over 1,600 plants worldwide, which equals around 2,000 megawatt of installed power. And most of those plants we are also managing in our service, because we see ourselves as a one-stop shop where we can provide not only the installation, but also the design of the plant, and also the service is a very integrated part of the system, because obviously the service is then, let's say, for the next 10, 20 years, depending on the running times of such an CHP unit. As AB, we are active in over 20 countries. You can see here a little map below the numbers where you can see the locations where we are present, not only with project management, but also with obviously sales and service structure. And the portfolio which we offer is quite limited, so to say. We have like three main pillars. First, and the one which we'll focus on today, is our cogeneration unit. You see it on the left. It's our EcoMax. It's the internal, or let's say the name of our modular solution. Then the newest addition to our product family is the biomethane upgrading unit, which can upgrade biogas to biomethane and can then, for example, be used in CHP units or can be fed into the grid. But this is, let's say, a new product portfolio using the membrane system, which we have developed and already successfully installed in many countries. And the third pillar is the air emission treatment system, where we produce ourselves SCR systems or RTO systems to comply with the emissions, especially for the cogeneration units. And I'm jumping now to the case study, but before diving in, I wanted to touch, let's say, the heating sector in Germany as a whole. Mr. Sadamori already mentioned it. It's a very, let's say, a sector where most countries are lagging behind when you compare it to the energy transition in the electrical energy sector, and you compare it to the heat sector, then mostly the focus is on the electrical energy sector. And also, I was quite surprised, to be honest, when I found out that half of the energy in whole Germany is used for this heating sector alone. It includes obviously also cooling, and is spread over all the sectors like private households, industry, and trade and commerce. But it's still, let's say, the biggest chunk of energy, and we speak about final energy consumption in Germany. And it's like a sleeping giant, I would say, because the focus was so far mostly on the electrical energy market. And the heating sector, when we speak about energy transition, where Germany is, let's say, very keen on doing it, so they want to reduce the greenhouse gas emissions by 65% in 2030. And therefore also the heating sector has to contribute its part. So therefore this district heating network as a part of the heating sector is a key player, because many, let's say, many industrial or let's say households are connected to one of those district heating networks. So when we make one of those more efficient, or to be more energy efficient, then all of those connected to this district heating network will have automatically the benefit from this. So this is a very big, let's say, or easy way to affect many industries which are connected to it. And also in Germany, there was a decision that we will phase out of coal very, let's say, fast. And this is also putting a lot of pressure on the whole heating sector as it is, because on the right side, you can see a little pie diagram, and still 20% of the heat is coming from coal. And this will have to be substituted in a very short period of time, where we need a very flexible solution which can deliver heat when we need it right now, so to say. So there's also CHP will play the extremely important part. But only so that we all, let's say, on the same level from the heating sector in Germany. I will now jump into this case study, this project I want to present. It's a district heating project from a utility which is placed in the middle of Germany. And let's say the frame conditions which we got as a initial point is that the company wants to substitute a very, very old CHP unit and want to extend an existing district heating network with around 5.4 megawatt electrical and 5.3 megawatt thermal power. And you can see on the right side from this Google Maps top view, this the red square is the place dedicated for this new CHP unit. So it's a very limited place where we had to design our system for. And also you can see this on the right side down here. There is a school next to it where we have also very, very high, let's say, sensibility on the sound emissions, which we will produce with our unit.
Hi, Philip. Excuse me. Hi, it's Ben from COGEN Europe. Just to say that we're not seeing your whole slide. There seem to be some blocks on the slide. Are those maybe? I don't know if you have any windows open. Yeah, that's made it much smaller.
Okay, perfect. Thank you.
And there's another one at the top of the slide. I don't know if, but anyway, that's fine now. We can see everything. Thanks.
Perfect. Sorry for this. Good that you mentioned it. Let me see if I can make this disappear too. See, full screen. Somebody has a tip. But anyhow, I mean, on the top, there are not a lot of information. So I hope now you can see most of it. I thought this was disappearing.
Yeah, it looks good now. Thanks.
Okay, thanks for the information. Like I said, on the right side, there is a school located. Now you can also see it. And the sound, let's say, requirements are very high for this location. This was another very important factor. And also in general, the integration of the system, you can also see here on the left side, two very big heat storage units, which had to be integrated. And also, let's say, the whole system had to be connected to gas and to the hot water connections in general, and also to the transformers. This is, let's say, only a frame condition from a technical perspective. When we look towards the substitutions, which were, let's say, aimed for this project, we are speaking about the Combined Heat and Power Act, the Kraft-Wärme-Kopplungsgesetz, it's like the German word for it. And there is a special tender incentive for such projects. It's via an auction where the bidder has to place the amount of cents per kilowatt hour which he would like to receive additionally. And then only let's say, a certain amount of the lowest bidders will get the substitution. So it's, let's say, a very complex system. I don't want to go into details, but let's say one limiting factor which you have to fulfill when you want to get this additional subsidy is that you can only run the unit 3,500 operation hours per year, which is very low and may seem very strange to some of you. So I will jump into this topic later on again and explain you why this is, let's say, the aim from the German government and what's behind it. So in order to fulfill those technical requirements, we went for our EcoMax solution, which is our CHP solution. And it's a containerized CHP solution, which can cover a range of 250 kW up to 4,500 kW per unit. Also multi-unit or module versions are possible, like in this case, and like a CHP in general, but also our solution in particular, we can design the system extremely exactly to the needs of each customer. So to say, when there is a hot water need or a cold need or a steam need or a certain sound requirement or mission requirement, the CHP systems can be modularly adjusted to all the needs, also in different countries, and maybe also temperature levels which you have in the outside. It affects the design of the system, and this can be very good reflected with our solution and with a engine-driven CHP solution exactly. And we have developed such solutions for now a very long time. So we put a lot of thoughts in the solution, and the, let's say, biggest downside when people would comment on a container solution is the accessibility. And you can see over the decades where we were redefining our solution, we obviously thought about this factor, and we installed a lot of accessibility via doors on the sides of the container wall. You can see this here, so that you can also maintain and do the service in a proper way for the engine, because this is at the end the longest period where we will interact with the engine. And also in regards to emissions, obviously there are solutions to fulfill every requirement in each country. So in Germany, it's mostly focused on NOx, and therefore we had to install a SCR, so a selective catalytic reduction system. This particular project solution, which we designed for this project, was 2 times our EcoMax 27 natural gas, which has a Jembacher gas engine inside, a 616 series, and it produces, each CHP unit produces 2,678 kW electrical and 2,582 kW thermal. And in order to, let's say, meet this very strong requirements on the on the sound emissions, we had to install, in addition to our super silent container, which already have a lot of additional, let's say, reductions, like special frequency converters, a very thick panel in the container walls, a very special silencer. We had to install, in addition, a sound barrier around the unit. You can see this in the picture down here. This was around 6 meters high, to reduce then the sound pressure level to around 50 dBA in 10 meters. And also, due to the space limitations, we had to install most of our additional components on the top of the CHP unit. We are speaking about the hot water decoupling system, the chimney, which was 24 meters high in total, the air inlet, the SCR. So all the components had to be placed on the container. The wall itself was designed so that we can destruct the engine and the container if needed. But this normally happens not before 60 or 80,000 operation hours. This is at the end the solution as built. You can see the project in different stages. On the left was at the beginning of the installation, and then on the right side you can see the finalized and commissioned system. It's running since then very, very good, and is producing the heat needed for this region in the middle of Germany very efficiently, and especially thanks to this double module solution, they can operate the plant very flexible. The result for the customer, for the end customer, for the utility, the biggest one is for sure that they have a more efficient district heating network, so that they can supply higher efficient heat to their customers. And obviously on the financial side, they had a plannable additional income due to the subsidy which they applied for, and they got the granting of it. And the limitation was, one was, I mentioned this already, that you can only operate the engine 3,500 operation hours per year. And the subsidy is only paid for 30,000 operation hours overall. So this calculates to around 8.6 years of funding period. And I assumed here in this calculation the best case scenario. So they get 7 cents additionally to the electricity sales and to the heat sales. And this equals around 11.34 million euros over the lifespan where they can calculate with. And this makes also obviously a big difference for such projects. But it's one of the results which the customer achieved with this solution. Another one is in Germany, district heating networks are measured by the primary energy factor, and they have to fulfill certain quality criteria. So he could, or the utility was able to reduce the primary energy factor, which equals also to a certain amount of CO2 savings. And obviously the OPEX costs were reduced dramatically due to the fact that the very old CHP units were first of all not so efficient like the new ones, but also the service costs were quite high because they were at the very end of the life cycle. So there was a major investment to be done, or a replacement like they did at the end. Also, and I mentioned this already in the slide before, they are very flexible now thanks to this double container solutions, and they can follow the heat demand perfectly without losing efficiency by running in partial load. And also in case that an engine has an issue, they still can produce certain amount of hot water, so nobody has to freeze in the winter. The potential future benefits from such a unit, and I believe that this utility already had this in mind when they installed it. I tried to put there 3 statements, and I will explain them now a little bit more in detail. So first one is more volatile energy markets in the future. And with all this increasing amount of renewable sources which are feeding into the energy grid, the volatility of the market will increase a lot. And this requires then obviously that there are some constant and flexible energy production units which can jump in case there is no sun and no wind available. And this is also, to close the loop, the reason why the government only grants this subsidy for 3,500 operation hours per year, because they want that the unit is operated in a way that it helps the grid. So we can, or the customer can freely decide when to run it, during which periods, and obviously he will check the energy price on the stock exchange and run the engine then when the price is the highest. And this is in Germany at least normally the case when there is no renewable energy feeding into the grid. So this is a subsidy which empowers them to run their engines at this times needed. The second thing is the flexibility in the future to reduce the CO2 footprint even further. It's in Germany at least also increasing amount of renewable gases in the gas grid. Now with the geopolitical issues, it will be getting a boost. So I think biomethane will be a big, let's say, will deliver a big contribution to this change. And the CHP units can be switched completely or partially to biomethane or even hydrogen. The engines are already ready to run with around 5% of hydrogen. And the question is more like in which changing intervals you will, the gas grid will change the hydrogen concentration. So there, the engines can run with those. And I think this was also said already by David. And this is a big advantage because you can adapt to future changes also on the available gas. Last but not least, this is a more integrated, intelligent energy system. We have seen this in the video very well. Like there are so many, let's say, renewable players which will feed in at the times where they can. And I see the CHP solution as a flexible puzzle piece. So it can adapt always to the needs of the whole system. And this gets more and more complex because more and more sources will feed into the grid. More and more regulations will, let's say, come in place. So we need a solution which can react to all of those changes, flexible, and can provide heat and electricity at these times where we need it. And there, the CHP is, I think, the only solution at the moment which can really fill this gap. And yeah, this was my presentation. I really hope you understood everything. In case there's questions, I think at the end of this panel, there will be a Q&A, so I will be happy to answer all of them.
Thanks, Philip. Yes, as Philip says, there will be an opportunity for Q&A at the end. So if you have a question for Philip or any of the subsequent speakers, do drop it in the Q&A box. So Philip, just quickly before we bring in Carlos, our next speaker, you said the geopolitical issues are giving a boost. So that means, despite the fact perhaps that, against the backdrop of the Russian gas issues and what they mean for Germany, perhaps in particular, you're optimistic, are you, about the future of CHP and COGEN going forward in Germany?
I am indeed. One very big change, which we can see also already in the political, let's say, agenda, is that the topics like biomethane and hydrogen to substitute certain amounts of the gas. This will obviously not work because we're speaking about a lot of gas which we get from Russia, and we're very dependent on them. But I think the government understood the importance of locally produced and very flexible energy solutions, which can help to balance then such a big, let's say, impact, which they didn't consider so far apparently, because we made ourselves very, very dependent on one supplier of of gas from Russia, which was, I think, looking backwards, a big mistake. But anyhow, now the government is acting in the direction of alternative fuels and is pushing them a lot. And we see a lot of potential in Germany and I think in Europe in general.